In this video, I want to have a look at mutually exclusive events and probability. So before we dive into any examples, we need to know a few definitions. So our first one is the word and. So if we're looking at probability and we've got an event A and an event B, then that means that our outcomes have to satisfy all of those conditions. If we're looking at the word or instead and we're saying the probability of it being A or B, then it has to satisfy at least one of them. So it doesn't necessarily have to satisfy both of them. It could, but it has to be at least one of them. The third definition is the term mutually exclusive. So if we say that events are mutually exclusive, it means that there's no overlap. So what that means is if we think about rolling a die, if we say odd and even numbers, they're mutually exclusive because there's no numbers that can be both on a die. If we have a look instead and say even and greater than 3, they're not going to be mutually exclusive because, say, 4 and 6, they're even and they also are greater than 3. So because there's overlap, they're not mutually exclusive. So it's really important when we're solving probability problems that we know whether our outcomes are mutually exclusive or not. Okay, so what all that means when we're solving probability problems is if we've got two outcomes, A and B, and they're not mutually exclusive, then if we're finding the probability of A or B, so it satisfies either A or B or both, then to find that probability, we're going to find the probability of A plus the probability of B, and then we're going to have to subtract the probability of A and B. So that's subtracting the overlap, because if we have the probability of A and the probability of B, then we've included that overlap twice, and we don't want that, so we have to subtract it at the end. If A and B are mutually exclusive, then because there is no overlap, this whole section here would just be 0. So the probability of A or B just becomes the probability of A plus the probability of B. So let's have a look at what that looks like with an example. All right, so our example says from 100 cards that are numbered 1 to 100, 1 is selected at random. And we're asked to find the probability that it is even or less than 20. So we're finding the probability that our card is even, or less than 20. So that probability, using what we just found, is going to be equal to the probability that it's even, plus the probability that it's less than 20. And because there are numbers that satisfy both of those things, there is overlap in those categories, we're going to have to minus the probability that it's even and less than 20. So we can find each of those things. So if we've got 100 cards, there's going to be 50 of them that are even. So we're going to have 50 over 100 plus the probability that it's less than 20. Well, there's going to be 19 of those. And of those 19 cards that are less than 20, there's going to be, so we're not going to add, sorry, we're going to subtract. There's going to be 9 of them that are also even. So there's 9 in that overlap. So there's going to be 9 over 100. So if we subtract that, we're going to end up with 60 over 100, which will simplify down to 3 over 5. So the probability that our card that we randomly select is even or less than 20 is going to be 3 over 5.